Hi National 5. So as we did yesterday, I've got a wee starter here that I would like you to do in the back of your jotters. I've split it again, so on the left hand side I've got 4 questions. I want my third years and the National 5 4th and 5th years to do these 4 questions, and on the right hand side I've got a question that I only want the third years to do. It's a wee balancing equation one. Okay, so the 4 questions: what type of bonding is found in metals? For question 2, I would like you to copy this out, but I would like you to score out one of these. So do metals lose electrons to become stable, or do metals gain electrons to become stable? Question 3, what do we call a free moving electron? And then question 4, what is made when metal elements are mixed together? Because remember, we can't get metal compounds. And then that one there, just do your wee balancing. Okay, right, what I want you to do, pause the video, complete the starter, and then once you've finished, unpause the video because I'm about to go over the answers. So question 1, what type of bonding is found in metals? That is metallic bonding. Okay, you should be getting that. Question 2, metals lose or do metals gain electrons? Now metals always lose electrons, and we spoke about that yesterday. Question 3, what do we call a free moving electron? We call that delocalized. Yeah, and then when we get multiple delocalized electrons, we call that the sea of electrons. Question 4, what is made when metal elements are mixed? Remember, we can't get compounds. They don't bond together, metal elements, they can only be mixed, and if they are mixed, it is called an alloy. Okay, so we get an alloy. Right, so 4th years, 5th years, that's you. I'm just going to move on to the 3rd years. Now to balance, remember the order that we're balancing. The first thing we should be looking for is group ions, but we don't have any here. So the next thing we go on to is metals, and we do have a metal, magnesium, and we write it underneath the arrow. Okay, after metals we balance non-metals, and we've got chlorine, and then we balance hydrogen and oxygen, which are also non-metals, so H. Now we've got 1 magnesium on the left, 1 magnesium on the right, we've got 1 chlorine on the left, and we've got 2 chlorine on the right, 1 hydrogen, and we've got 2 hydrogens on the right. So this isn't balanced. So start at the top, magnesium is, so we don't have to do anything. So we go down to chlorine, focus on the smaller number, okay, which is the left side. So what do we need to do in order to get this number to equal that number? We need to times it by 2. So where does the 2 go? The 2 goes in front of the HCl, because remember it can't go in the middle and we can't put it at the end, so it goes at the front, and that multiplies everything in the molecule. So what happens is that H now becomes 2, and the Cl also becomes 2. And have we balanced this equation? Yes, we have. Okay, so that's a nice easy one. So I hope you get on okay with that. Right, what I want you to do, we're just going to carry on, so go to the front of your jotter. Again, you can pause the video until you do that, and I want you to put the subheading, because we're just going to carry on from yesterday's lesson, the subheading, properties of metals. Okay? Now, I want you to put melting and boiling points. So, metals have high melting and boiling points. Okay, that's why the majority of them are solid at room temperature, the only one being mercury, which is a liquid. at room temperature. So metals have high melting and boiling points, and this is due to the metallic bonds found in metals. Okay, so if we go back to this here, you don't have to, but remember the metallic bond is between the delocalized electrons and the positive metal ion. Okay, so that's your metallic bond. Now the reason that metals have such high melting and boiling points, so this is due to metallic bonds found in metals. Metallic bonds are extremely strong and require a lot of energy. Okay, and that's a key word there. That requires a lot of energy to break them. Okay, and that's why the metallic bond has such a high melting, that's why metals, have such high melting and boiling points, is because they contain a lot of metallic bonds, and metallic bonds are so strong that we need to put in so much energy in order to break them apart. Yeah. Now the next thing I want to talk about is conductivity. Okay. Now from first year, you should know that metals, let's change that. All metals conduct electricity. Okay, you learned that in first year. All metals conduct electricity. Now, let's just make a wee note about electricity. Electricity, to try and simplify this as best I can, electricity is the flow of electrons. Okay? Now, since metals contain a sea of electrons, so that's multiple delocalized electrons, so it contains a sea of electrons. So since metals contain a sea of electrons, this allows electricity to pass through. Okay, and that's why metals conduct electricity. It's because of this sea of electrons, and that's so important. Okay, because you can get asked about that. Right. Do I start here? In fact, you know what? I'll start. No, you know what? I'll start here. In fact, no. Let's pick a new page. So we've done metallic bonding. Okay. Now what we're going to go on to is my favourite type of bonding, covalent. Now, covalent bonding is found between non-metal elements. Okay, so metallic bonding is found between metal elements, covalent bonding is found between non-metal elements. So make this wee note here. So both non-metal elements and non-metal compounds contain covalent bonds. Okay, so if we go for an example of non-metal elements, that could be hydrogen, okay, which is H2, which looks like that, yeah. So that there, that wee sort of line that's holding the two hydrogen atoms together, that's your covalent bond, okay? You could also have, let's say, chlorine. Which is Cl2, which is Cl bond Cl, and again, that bond, that wee line between the two chlorines, that's your covalent bond. Okay, that's what's holding the two non-metal atoms together. Yeah? Now, if we go for non-metal compounds, now remember, have a wee think of what a compound is. Okay, a compound is when you've got two or more different type of atoms. So if we go for water, most of you should know that water is H2O. Okay, now water actually looks like that. You've got one O, you've got a H, and you've got another H. I'll maybe do this in a different pen actually. And those two bonds there, that's your covalent bonds. Okay, that's what's holding the non-metal atoms together. Yeah. Another one you could have is ammonia, which is NH3, and that looks like if we were drawing this as like a 2D shape, probably look like that. And again, those three bonds there, 1, 2, 3, that's your covalent bonds. Okay. Now, if we think back to metallic bonding is all about metals losing electrons. Okay, covalent bonding is a wee bit different. Okay, covalent bonding involves the sharing of outer electrons. Okay, and that's important. I would make a big deal about that word sharing. Okay, so covalent bonding involves the sharing of outer electrons. Okay, now just make a wee note. Remember, atoms want to have a full outer shell of electrons. Okay, that's all atoms want, and we spoke about that. We spoke about that when we did atomic theory. We spoke about that when we did metallic bonding. We're coming back to it again because it's so important. All atoms want is they want that full outer shell of electrons, and they do that, non-metal atoms do that by sharing outer electrons. Okay? So, can you see that? Yep. So the shared pair of electrons So the shared pair of electrons that holds the non-metal atoms together is called the covalent bond.